years, we have called the coil on the inside of the house the evaporator coil. Now with heat pumps, we call the evaporator coil the indoor coil because with a heat pump, sometimes the indoor coil is the condenser and sometimes it is the evaporator, depending on whether we are heating or cooling. The evaporator is a heat exchanger that absorbs heat into the refrigeration system. It receives cool, low-pressure refrigerant liquid from the liquid metering device and changes it into refrigerant vapor of about the same temperature as the liquid. The refrigerant comes down the liquid line as a high-pressure, high-temperature liquid as it enters the metering device. As the refrigerant goes through the metering device, it stays a liquid, but it goes from a high-pressure, hot liquid to a low-pressure, low-temperature liquid. In the evaporator, the refrigerant evaporates and changes state to a vapor. It changes state as it is absorbing the heat from the air flowing across the coil fins. As it absorbs this latent heat, it evaporates or changes state. In the latter portion of the coil, the liquid has turned into a vapor, and in the last passes of the coil, we add sensible heat to the refrigerant to ensure there is no more liquid contained in the refrigerant. This is our superheat. This diagram shows the work done in the evaporator. Our liquid refrigerant enters the evaporator at 212 degrees, and in the evaporator it absorbs heat and changes state to a vapor while the temperature stays 212 degrees. After it has changed state, we add sensible heat to the vapor to make sure all the liquid has evaporated and we do not have any liquid present. This is our superheat. Latent heat is the energy of molecular separation and arrangement. It cannot be measured by a thermometer. In the latent heat process, heat is added until the liquid boils, and as it continues to boil, the water changes state to a gas. The temperature does not change, but the state changes. In this example of the work done in an evaporator, the incoming air is 80 degrees, and our coil temperature is around 53 degrees. So we know that the cooler refrigerant inside the evaporator coil will absorb the heat from the air circulating across the coil, and the air leaving the evaporator coil will be 15 to 25 degrees cooler than the entering air. In order to measure our superheat that we add to the refrigerant at the end of the evaporator, we need to take a pressure reading at the suction service valve or the dedicated suction port on a heat pump. We then want to convert that pressure into a temperature by reading our gauges or a PT chart. We then take a temperature reading on the suction line at the outdoor unit and subtract these two temperature readings. In this example, our 68 PSIG R22 reading converts to 40 degrees, and we read 52 degrees on our suction line. By subtracting these two values, we come up with a 12-degree superheat for this system. It is critical that the evaporator coil be kept clean and correct airflow maintained over the entirety of the coil. Charge is critical for proper system operation, but before any changes are made to the system charge, you must make sure you have a clean coil and filter and you have good airflow over the entire face of all slabs of the coil.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.